guys, it's Hoffbauer again. We are doing some more stuff with factoring like we started yesterday or in the last video, I guess probably the same day. But we're going to solve now. So we have an equal sign somewhere so that we can actually solve. So we're going to start out by talking about when you can just square root. Notice there's an x squared here, but there's no other x term. So what we're going to do is just isolate the squared quantity. We get 3x squared equals 21. And then we're going to divide by 3. And we get x squared equals 7. Now this is really important, but if x squared is 7, there's actually two answers that work. Whenever you square root an x, the answer is actually the absolute value of x. And then you square root of 7 and you get square root of 7. And if you remember, absolute value means there can be positive or negative. So we usually just skip that step and we write down that square rooting x is x, but square rooting 7 is either positive square root of 7 or negative square root of 7, which we could write separately or like this. Okay? If you were to graph x squared equals 7, or you would get a parabola that looked like this. And if you graphed a 7, you'd get a line that looks like this. And there's two possible solutions. So that's why we have to remember that there could be a plus or minus. All right, now, some of you would be real excited and you'd want to FOIL this together. You'd go x minus 3 times x minus 3. And then you'd FOIL that all together, and then you'd move the 5 over, make it equal to 0, and then you'd factor all over again and find the solutions. But if you can isolate the quantity here, the squared quantity, then you can just square root to get rid of the squared. So we would be left with x minus 3 equals, and you do have to remember that plus or minus the square root of 5. Square root of 5 is ugly, so we're going to leave it as an exact answer. Now, this is, I still wrote it in parentheses, but they're not doing anything over here. So all we have to do to isolate the x is add 3. Now, you have to be real careful how you write this, because it is 3 plus the square root of 5 or 3 minus the square root of 5. And you can write it 3 plus or minus the square root of 5, but you have to be real careful. The 3 is added, not multiplied. So you can't write plus or minus 3 square roots of 5 or some crazy business, okay? Now, we have one more of these, but this is the one that usually gives students trouble because they want to distribute or something. You can't distribute because of that squared up there. You'd have to FOIL it all out first. So if I did this super fast, the long way, you'd have x plus 2 times x plus 2 would give me x squared plus 2x, and another 2x would be 4x, plus 2 times 2 is 4. That's all multiplied by a 3. Then I have a minus 10 equals 65. I'd get 3x squared plus 12x plus 12 minus 10 equals 65. If I made it equal to 0, I'd have 3x squared plus 12x. 12 minus 10 is 2. If I subtract 65, I get minus 63. Then I have to take a 3 out, and then I have to factor. Phew, it's giving me a headache. There's a faster, easier way, because some of you would have already made a mistake doing it that way, and you still have to finish. The faster, easier way is to isolate this quantity. So we're going to just ignore the squared and everything right now, and we're just going to look at it as an Algebra 1 problem. In Algebra 1, you would have added 10. And maybe you would have divided by 3 to get rid of that 3. Even though there's parentheses, we can't distribute because of the squared. So we have an x plus 2 quantity squared equals 25. Then we can just square root. And we got to remember our plus or minus, the square root of 25 is 5. So now we have to be a little bit careful. We're going to subtract 2 over here. And since we're in Precalc, I'm going to require that you tell me what that means. So we have a -2 and a plus or minus 5. So -2 plus 5 would be 3, and -2 minus 5 would be -7. So x is either 3 or -7. We got our two solutions, okay? And we didn't have to do any factoring or foiling out or anything crazy. All right, I'm going to go ahead and get rid of this so that someone doesn't look at the notes and think they had to do that. All right. Now, completing the square, I have a couple examples of this on here. Solving by completing the square is not usually a choice most of us would make. The only reason it's in this chapter is not so much for solving, but when we go to vertex form, we're going to need to do completing the square. So we're going to practice what this meant. Completing the square meant you moved the constant over to the right-hand side, and then you rewrote everything with a blank. Anybody coming back to anybody now? This business about putting a blank in there? Then the idea is that this quantity needs to be something squared so we can solve it the way we just did the last set of problems. To do that, we square root the first term and we get an x. And then we need to figure out what something times itself foiled together to make this quantity that had a 6x in the middle. So it had a 3x and a 3x. And the last term would have been 3 times 3, or 9. So the general rule is, always works, you take half of this. So you take that b, divide it by 2. So half of that would be 3. And then you take that term and you square it and put it back here. And whatever you put in this spot, you put in this spot. And then you just simplify. 7 plus 9 is 16. And now we can square root both sides. I just rewrote it so I didn't mess anything up by scribbling all over the top of that notes. But this would square root to just be x plus 3, and this would be plus or minus 4. Square root of 16 is 4. We got to remember the plus or minus because we square rooted an x squared. All right, then we subtract 3 over to the other side. And that gives us, I don't know why I wrote that so messy. The videos end up too long because I can't be neat. Okay, so -3 plus 4 is 1. -3 minus 4 is -7. And feel free to, type those in your calculator. Don't make a silly sign mistake because you forgot your negatives and positives over the quarantine. Okay, moving on to this one. Again, we just put a blank in because the 11 is already on the other side. If it wasn't, we'd have to move it over there because we don't want any constant term here. Then we take half of the b term and put it down here. So it's -10, so half of that is -5. And then if you wrote that out, x minus 5 times x minus 5, and you did all the foiling, you'd get a -10x, but -5 times -5 would be 25. So now this factors down to this. Those are equivalent. But since we added a 25 to the left, we got to add a 25 to the right. And then we get a square root. And we get x minus 5 equals plus or minus 6. Add 5 over to the other side. And we get 11 or -1. I did that right. 5 plus 6 and 5 minus 6. All right. One more of these completing the square jobbies, but this one is icky because it has fractions. I really like you to learn to work with fractions this year. It's kind of one of the important things that you need to be comfortable with as we go through pre-calc. This one we do need to add the 4 over to the other side. And then we're going to put the blanks in. All right, Then the concept is we're taking half of this, so we're going to write that as x plus 13 over 2. That wasn't too confusing yet, right? Now, 13 over 2, when you square it, means 13 over 2 times 13 over 2. So 13 times 13 is 169, and 2 times 2 is 4. So we add a 169 over 4 to both sides. Now, to make life easier, let's just jump onto the calculator, which unfortunately I don't have turned on yet. So we have 4 plus 169 over 4. Some of you are really good with fractions. If you needed a common denominator, the common denominator would be 4. So you would change that 4 to 16 over 4, and then you'd add the top and keep the denominator. But it's okay to go 4 plus 169 divided by 4. And you could put that in parentheses, but it wouldn't make a difference here. Then do your math, enter, enter. We end up with 185 over 4. Remember I said this is really 16/4. Add those and you get 185. Keep the denominator. All right, then we can square root both sides. Now this actually comes out kind of nice because we have 13 halves over here. The square root of 165 is, I don't know, but I'm going to leave it square root of 185. Did I just say 165? I'm sorry. The denominator, though, the square root of 4 is 2, which is a wonderful thing because remember, we're not supposed to have a square root in the radical according to some crazy mathematician rule. So we didn't have one here. We're good. So all we need to do is subtract the 13 halves over to the other side. Should I hereby solemnly swear I won't put this on a quiz? Actually, it's very good practice, but it's probably not on the quiz. So we end up with x equals a negative 13 over 2 plus or minus the square root of 185 over 2, which could be combined into a single fraction. And I'm only going to mention that because it's very important when we get to the quadratic next week, quadratic formula, that we understand writing this as a single fraction is the same as writing each piece over 2. All right, now we're going to do some quick factoring, and then this video will be done. The zero product property says that if you have a times b and it's equal to 0, then either this has to equal 0 or this guy has to equal 0. That's true. The only way that can happen is one or the other of them is 0. Okay? So that's the whole idea behind factoring, is if we must set everything equal to 0 first, and then if we separate it into a multiplication problem, we can say one or the other of them has to equal 0. Well, this one, we take out a common factor. Can you remember that? Take out a 4 and an x. And we took a 4 and an x out. There would just be an x minus 4x. Be a 2. 4x times 2 is 8x. All right. Now we have two things, kind of, almost three things, that multiply to make 0. You could say 4 equals 0. Well, it doesn't, so you'd have to throw that one away. Or you could just say 4x equals 0, divide by 4, and you still get 0. 4 is not a solution, okay, guys? If you put a 4 back in here, you do not get 0. If we set this one equal to 0, add 2 to both sides, and we get x equals 2. I don't know why I'm confusing myself. 4 squared is 16 times 4 is 64, minus 4 would be 32. Okay, yeah, putting a 4 in doesn't work. For some reason I looked at it and thought it did work, and then I was really confused. All right, just crazy teacher here. This is factoring again. We're pretty good at these kind. Just to get an x squared, we have an x and an x. To get a 9, we need a 9 and a 1 or a 3 and a 3. I'm thinking a 9 and a 1 will give us 8. Now we need a negative 9. And does that work to give us a negative 8 in the middle? Negative 9x plus 1x, checking that middle term. All right, then to solve, we just need to set each piece equal to 0. X minus 9 equals 0. Add 9 is x equals 9. X plus 1 equals 0. Subtract 1, we get x equals negative 1. Either one of those solutions will work. This one is called, anybody remember? Difference of squares. It is a binomial. Both of those numbers, x squared and 49, are perfect squares. So we just go x plus and x minus, and square root of 49 is 7. So we have 7 and 7 equals 0. If we set this one equal to 0, we get negative 7. If we set this one equal to 0 and add the 7 over, we get positive 7. So x is either 7 or negative 7. You could have solved that one without factoring. If you'd added the 49 over to the other side, you would have had x squared equals 49. And then you could have square rooted. And just remember, it's plus or minus. Okay? So that one can be solved either way, just don't lose one of the solutions. All right, 3 more trickier factoring problems. First of all, must equals 0 before you can factor. So 3x squared minus x minus 10 equals 0. Or x squared minus 6x, to move this over, we'd add 8 and subtract 3. I don't know why I felt the need to do all 3 of those at once, but now we're just going to factor. So to make a 3x squared, I need a 3x and a 1x. To make 10, I could have 1 and 10. I'm thinking it's probably 5 and 2. I am thinking 3 times the 2 would give me 6. And then 5 times the 1 in here would give me 5x. And I need them to add up to negative 1, so I need a negative 6 and a positive 5. That makes a negative 1 in the middle. Okay? However you factor that, trial and error till you get this answer. But this is ones you got to be careful because the answers are not negative 5 and 2. Some of you just want to just grab those change signs out of the middle there. 3x plus 5 equals 0. You have a couple steps there. You have to subtract 5 from each side and then divide by 3. So you get x equals negative 5/3 as one of the solution. The other one is easier though. X minus 2 equals 0 just gives you x equals 2. All right, and you don't have to write or. I don't remember how it works on the program. We'll have to review how Delta Math does it, but all right. X squared minus 6x plus 8. Factors that make 8, but add up to 6 would be 4 and 2. To multiply to make a positive, but add to 2 negatives would have to both be negative. I don't even think I needed to do that one. I think you're good on that guy. All right, 2x squared would be a 2x and a 1x. To get a 3, oh, that's easy. Like if I put the 3 here and the 1 here, I get 6x and 1. That's not make a 1 in the middle. Okay? So if I switch those around, I get 3x and 2x when I multiply. If the 3 were negative, 2 times 1 is positive 2x. Then when I added those two together, I'd get the negative 1 in the middle. And negative 3 times 1 is negative 3. All right, so 2x minus 3 equals 0. If I add 3, I am not going to be showing all these steps much longer, guys. I hope you're okay with that. And over here, if I had x plus 1 equals 0, I'd have, I think Hoffbauer's going to have to slide off the bottom here. I would have x equals negative 1 as the other solution. All right. So real quick, finish this video up. Which method seems the best? Now, somebody is going to look at this and think they have to make it equal to 0. But there is no x on this term, so we actually could add the 24 over here and isolate the x squared. Let's see, that's 30, 40. And then we would square root. And that would give us x equals, don't forget two solutions anytime you have a squared, plus or minus. And then the square root of 40, I would really like you to practice simplifying. The square root of 40 is 4 times 10, and one of those had to be a perfect square so that he could get out of jail. Okay, so if I write, probably should have done the perfect square first. The perfect square that goes into 40 is 4, and it goes in there 10 times. So then the square root of 4 is 2, and then I have the square root of 10 has to stay in the little radical. Now, it is not 2 plus or minus the square root of 10. This time it is positive 2 times the square root of 10 and negative 2 times the square root of 10. So be real careful you don't do something weird with the algebra. All right, I'm thinking this is a factor problem. I'm not going to bother to do this one. We could take a 3 out of everything first. So we'd end up with x squared plus 4x minus 21. And keep your 3. Factors of 21 that make 4 would be 7 and 3. Check that you get a negative 21, and if you do inside and outside, you get a positive 4. Now, this is where students do crazy business. Can this 3 equal 0? There's 3 things multiplied here. Either 3 equals 0, or x plus 7 equals 0, or x minus 3 equals 0. Well, 3 cannot equal 0. That's garbage. But x could be negative 7 or positive 3. Now, it's weird that we threw 3 out as a solution here, but it works here. If this had been a 5 out front, it would have just got thrown away. It just happens that the same number was used twice in that question. All right. Tricky. Anybody remember what we could do here? Last minute of the video? No? We can isolate this. We don't have to distribute, can't distribute. We don't have to FOIL it out. We could just add 12. 77, if I did that right. Divide both sides by 7. Then when we square root, we get x minus 2 equals plus or minus the square root of 11. And if we add 2 over to that side, it's not multiplied, so it's not 2 times the square root of 11. It's 2 plus or minus the square root of 11. Which some teachers would make you write 2 plus the square root of 11, 2 minus the square root of 11. I'm either okay with either one of those possibilities. All right, so that's solving with quadratics, some of which you want to factor, some of which there's an easier way. I don't think I assigned completing the square in the practice, so it's either factoring or square rooting, I think. All right, good luck, guys. I think this is my last video for week 1, so have a great weekend.